Hey Kata, wanna talk about C++ coroutines for real this time?
Yeah, but I want to make sure that it's for real. So, this next band. Sorry.
Okay, let's start from the beginning. Okay, uh, I want to start with a quote from Scott Mayers, and you can then see the full talk here. I actually suggest you to take a look at it, which talks about C++, which says that C++, in contrast to other programming languages, is a language for library writers. It is not really a language designed to say, let's write applications. And that this is true. I mean, if you look at C++, when they introduce a new feature, they always think about the generic case and they think more about what can library writers build with this, and think about, I don't know, template meta programming. That when they wrote the language, they didn't even think about it. And so this is a really cool feature of C++, but it makes it a bit complicated to reason, because if you look at most of the talks out there, they look at the library writer's perspective. So that's for later. For today, we are going to
Yeah.
focus on the library user. So the one that gets a library that uses coroutines and just needs to use it. Okay,
Yeah,
so
but show me
yeah.
something.
Okay, so
Make it short.
to give an example, I built for
Yeah.
you, just for you, because I know you love JavaScript.
Yeah,
Uh,
yeah, yeah, absolutely.
I built a library that mimics the the promises and async functions and the await facilities in JavaScript. And this library is called Pledge.
Hey, but why not promise? We already have the promise.
Well, there are already two things in the C++
Yeah.
standard that are called promise, so I didn't want to
Okay.
add a third one. So
Okay.
let's
So
call
you're
it
rewriting the
Pledge.
wheel without saying that you want to rewrite the wheel. Perfect.
Exactly. So these things are pledges, not promises. They are pledges. Okay.
Pledge on you. Okay, not yet.
Okay. So the TLDR on the JavaScript promise is that you have this thing that gives you access to some computation that is going to come later, either because it's an asynchronous computation, or because it's
Mhm.
a micro task, or it's attached to some asynchronous event. You just know that it's there and you can wait for its termination. And so
Okay.
Pledge, same thing. So it provides the same exact functionalities. And just to be clear, we're assuming that every one of you knows what the promises in JavaScript do. If
Yeah.
you
If
don't
you don't
know,
know
yeah,
what they can do,
well, they can leave
I
a
don't know.
comment down below asking for an episode about it.
Yeah. Makes
Well,
sense.
or other ideas, but yeah,
So leave a comment.
yeah, leave a comment down below. Okay, so assuming that you know, let's go.
And leave a comment also if you know.
That's fine. Let's say that you have three ways of building
Yeah.
a pledge. One way is the one that is used to wrap existing asynchronous APIs. So you go,
Mhm.
you build a pledge, and you provide a function that is going to be invoked later, and at which is going to be provided a resolve callback. And when you call this callback, the promise is going to be fulfilled. So in this
Okay, nice.
example, I'm providing an equivalent of JavaScript's set timeout, and I'm wrapping it into a pledge. So
Okay.
yeah, the idea is that we are building a pledge of void because there's no value returned. It's like a promise of void. So what is happening is that we have a duration. We are doing this computation to take into consideration the potential delay in the initial scheduling. So
Too precise for me. No,
yeah, I
I
want
know.
to be
I'm joking.
precise. So we compute the
I'm
time at
joking.
which we want
It's
to
okay.
trigger.
It's right. Yeah.
Then we call internally and during the execution of the initialization of the pledge, we are going to call this asynchronous API, which is set timeout. We are passing the callback because this is the one that we want to be called, and then we compute the actual duration now. So
Yeah.
this function
Perfect.
takes a duration and returns a pledge of void that is going to
Yeah.
be
Yeah. Yeah.
fulfilled when it's there. Then we have other ways to build a pledge. Well, we have the way with a coroutine, an actual coroutine. So how do
Okay.
you understand that a function is a coroutine?
I don't
Well,
know. Go wait. Go
yeah,
return. Go
yes.
something.
Any function that contains the coroutine keywords, so co-wait, co-yield, co-return, it's a coroutine.
There is
And
also a co snack routine.
no, it's fortunately not, but you can propose it for C++ 26 or probably 29 or something. Okay, so when this now that we know that this function is a promise, the return type changes meaning. It's not the type that is returned, but it's the type of the handle of the coroutine object that is returned to the caller. And in this case, we made pledge compatible with this. So if you say that you have a pledge and you have a coroutine inside, this is just going to go there. The type of the pledge tells you what is going to be the final return type of the coroutine. And inside, you have your co-wait, where if you have other pledges, you can go and wait for them. So in this case, we say that when you call get world, we're going to wait, we're going to use this helper. And this is interesting. This doesn't need to be a coroutine, it just need to be a pledge. So independently on the way it is built, the co-wait is going to work regardless. So we're waiting for a second, and after a second, we're going to return. And what's going to happen here is that the coroutine is going to get paused, it's going to be put aside, waiting for the wait pledge to get fulfilled. And when that gets fulfilled, is going to be put back, restored, and restarted. This is not a thread. There are no resources wasted keeping this alive. There is no physical thread block there waiting. All these things are frozen, are suspended, and are moved to a queue waiting to be processed. And when the pledge we are waiting for finishes, it's going to be put back in the queue, and it will restart computing. And there is a third way to build a pledge, which is, again, it's a mirror of JavaScript, where you can build a pledge that is already fulfilled. So pledge, resolve. And it's interesting to see that in all three cases here, independently on the way they are implemented, this function have the same signature. They return a pledge of something. They may or may not have arguments. It depends. It's independent. And they're just going to work. They're there. And you don't know when you call them how they are implemented. The magic sauce, it's all hidden away, and it's the responsibility of the library developer to do it. If you're a client, a library user, you don't care about it. That's the interesting thing. The library writer did the complex work for you. So again, this just works. So let's go and let's write a more complex coroutine.
Yeah.
And in this case, what we're doing is that we're building three pledges. And the first one is just a delay pledge. So we want to say that we don't want to do anything for 3 seconds because reasons.
Oh, delay. Okay.
And at the same time, you already start the computation of two other pledges, which is a pledge for the world hello, and a pledge for the world. Sorry, for the word
really complex
world.
tasks.
Yeah, extremely complex, but they're defined up here. So then we go, and these three are going to start the computation, are going to be put in the queue to be started, and following its own rules. And then we have here our co-await, which is going to wait for the first one. It's interesting because the pledge doesn't need to be awaited right away. You can build a lot of pledges. You can do stuff to them, doing some computation before you actually await. And
It's nice.
yeah, and after this, you can go, and we are going to go and await on hello, and then we are going to await on world. So what's your expectation here?
I suppose that it go on when it gets the data. So probably you have the hello, then you have the space, then the wait, then the world. Sorry.
Yeah, but I mean, look at it. They're all coming out at the same time, right?
Yeah, but can you, I don't know, make the line 25 a bit longer?
Exactly, because we are saying that we want to wait at least 3 seconds, and this one is waiting for 3. So if we move this to 5 seconds, and this is the second pledge effectively. Yeah.
So we can say that in this video we don't mishandle the threads.
Yeah. And there are no threads here. Everything is magic. It's there. It's working. And
wow,
yeah, so this
nice.
is interesting part. So it is effectively, as you saw, let's redo it. This is effectively going and stopping after a low because it's waiting for the other co-wait. And all of this is happening without you having to think about it. Think about writing this with callbacks. It will be
really nice.
Callback hell, and you need to copy all the data or move all the data and do all this stuff and wait for them. And
it's all natural.
Yeah, so this gives you the power. And this is just one of the ways in which coroutines can be used. This is just an example. And this is just an example that we provided. You can build way more complex and way more simple and way more different things, whatever you want with them.
We can do that in some other video, or we can also take to the library implementation, but I think that our friends need some snacks. Can you hear it?
Yeah.
It's snack time.
It's snack time. Okay, so see you next time, folks.
Bye.